In today's Calc 3 tutorial, we are going to go over tangent planes and linear approximation, and while this does look intimidating with the equation given over here, it really isn't that bad. I'll just explain how it works. But at a given point, x0, y0, and z0, we're given the equation z minus z0 equals the partial derivative of f with respect to x of x0, y0 times x minus x0 plus the partial derivative of f with respect to y of x0, y0 times y minus y0. Now, as a reminder, x0, y0, and z0 is just the point where the plane touches, and then the partial derivative of f with respect to x is just the rate of change in the x direction, and the partial derivative of f with respect to y is just the rate of change in the y direction. Now, for the linearization part, which is given here, it looks super complicated, but once you get your tangent plane, this is extremely easy. So let's get into a problem. So our first problem asks us to find a tangent plane to z equals the square root of x squared plus y squared at the point 3, 4, and 5, and use it to approximate f of 3.01, 3.98. So just like the previous tutorials, I'll just summon a checklist, with the first step being given as find the partial derivatives. Now we can rewrite z equals x squared plus y squared in parentheses to the power of 1/2, since it's the same thing as this, but we also know that the derivative of the square root of x equals 1 over 2 square root of x. So with the exact same logic, we can just simplify our partial derivative of f with respect to x as 1 over 2 times the square root of x squared plus y squared times 2x, because we use chain rule to find the derivative of the exponents under the square root. Now the same exact thing goes for when we find the partial derivative of f in respect to y, where it becomes 1 over 2 times the square root of x squared plus y squared. But since we're using the terms of y, this x squared disappears, and we just multiply by 2y. Now simplifying even further for both of these, this can become 2x over 2 times x squared plus y squared, and this can become 2y over 2 times x squared plus y squared. And then we could cancel out the 2's, leaving us with x over x squared plus y squared under the square root, and y over x squared plus y squared under the square root. We can now check the first part off our list and look at the next part, being evaluate at the point given. So in our problem, we are told that our point is 3, 4, and 5, which I'll write down here. And we know that that 3, 4, and 5 is the same as our x naught, y naught, and z naught. So all we do is just plug in these numbers into the equations we wrote over here, giving us 3 over the square root of 3 squared plus 4 squared. And on this side, 4 over the square root of 3 squared plus 4 squared. Now, of course, both denominators are the same, and they simplify to the square root of 25, which then gives us 5. So then this becomes 3/5, and this becomes 4/5. So far, I just got the partial derivatives with the given equation, and I evaluated it at the point given. So I'll give these labels as respect to x and respect to y. So now we can check step 2 of our list. Now our next step is to use a tangent plane formula, which, if you recall, is this formula over here from the beginning. And because this looks so complicated, it looks overwhelming to memorize, but in reality it's not. All we do is just mark out these x naught and y naught and x naught and y naught, since that's just too specific. There's no point of remembering that. So we can look at it as z minus z naught equals respect to x times x minus x naught plus respect to y times y minus y naught. And this is a lot easier to remember and look at. So we literally know all of these variables. Again, reminder that our point is 3, 4, 5, which is again x, y, and z. And given our points of respect to x and respect to y, all we do is plug. So this becomes z minus 5 equals 3/5 times x minus 3 plus 4/5 times y minus 4, which we could turn into decimals if we wanted, and that is what I prefer. So I'll rewrite it really quickly. 3/5 is the same as 0.6, 4/5 is the same as 0.8, and now all we do is distribute. So this becomes 0.6x minus 1.8 plus 0.8y minus 3.2. We can then add the 5 from the left side, giving us 0.6x minus 1.8 plus 0.8y minus 3.2 plus 5. Now, luckily enough, negative 1.8 minus 3.2 just becomes negative 5, which then means we could cancel this 5 and this 5. So we are now left with z equals 0.6x plus 0.8y, which is our tangent plane. Now, that's the first part, but now we need to go to the second part, which is use linear approximation with the points given. So we are asked to approximate with the points 3.01 and 3.98. And so looking at our linearization formula, we recognize that this L is the same as our Z. And so we can replace that Z with L equals 0.6x plus 0.8y. We could then evaluate our L with the 3.01, 3.98 given, which is just substituting numbers into x and y, leaving us with these values. Now, after further evaluation and simplifying, now our final answer becomes 4.99. So our final answer is that our tangent plane is z equals 0.6x plus 0.8y, and our approximation is L equals 4.99. And so that is how you do the tangent plane and linear approximation. Thank you guys for watching, and good luck on your exam.